Welcome back to my video series about how to build a sub 250 gram 3-inch freestyle drone for absolute beginners who have never built a drone before. This is a video series, so if this is the video you were looking for, then great. But if you just stumbled across this video, then feel free to watch it. But if it feels like you're coming in the middle, that's why. There is a playlist linked in the video description below that has all the videos in this series. And if you're not sure what the heck's going on here, then you should go back to video number 1 and hopefully it'll all make sense. A whole bunch of the content in the video that you're about to watch is borrowed from my previous build series where I built a 5-inch drone. I just couldn't bear to re-record hours and hours of content that was going to be exactly the same, except instead of me holding a 5-inch drone in my hand, I'd be holding a 3-inch drone. I'm going back through these videos, and anytime there is a content that is unique to the 3-inch drone that you're building right now, I'm going to record that and I'm going to edit it in. But if there's a whole bunch of this video where I'm talking and I'm holding a 5-inch drone instead of a 3-inch, don't let it confuse you. It still applies to what you're doing. Unbox the motors and take them out of their plastic bags. The motors come with 3 sizes of screws, and it's probably a good idea for you to sort them out like you see I've done here, so you make sure you're using the right size. There are 4mm, 6mm, and 8mm screws. We're going to use the 4mm screws to mount the motors to the frame. And let me show you how I know that that's what we need to do. I'm going to take the screw and stick it up through the bottom of this plate, and you see it protrudes out about the same amount as the thickness of the motor base. The screw is just a little bit shy of being as tall as the motor base. That's a 4mm screw. If I grab a 6mm screw, how does it look? With a 6mm screw, we can see it extends just a little bit past the motor base, but not that much. I actually think the 6 is going to be the way to go. What we want is, we want the maximum amount of thread engagement between the screw and the motor base. Especially with these little M2 screws, we need all the threads we can because the M2 screws are really easy to strip out. But if we use a screw that's too long, we can get a situation where as we tighten the screw down, it extends up so far that it cuts into and touches these windings here, and basically that just destroys the motor. So I always double check my screw length in the way that I just showed you before I start assembling a new frame to make sure that the screws are the optimal length. And it's not a bad idea to just have a screw assortment, like just search on Amazon for M2 screw assortment or M3 screw assortment, and for 10 or 15 bucks you'll get one of every size you could possibly need and be ready to go. Or you could just buy a frame that comes with the right size screws. Go fig. So I'm going to get this plate from the frame kit and I'm going to install the motors onto it like this. One at each corner with the wires facing inwards. There's going to be 4 screws per each one. And what I suggest you do is, you're going to use a 1.5mm driver. That's the right size driver for these screws. And what I suggest you do is just loosely thread in all 4 screws before then tightening them down. If you tighten them down too early, it could be hard to get them lined up. If you're inclined to use blue Loctite on these screws, you could use just a little bit of blue Loctite to keep it from backing out, but I just make sure they're snug, and usually that's good enough. I do want to tell you, as you're torquing those screws down, you definitely want to get them snug. You'll feel them start to tighten up, and then you'll get maybe another quarter turn on it, and you'll feel it get snug. You can easily strip these screws out, and the motor bases are aluminum, so you can easily strip those out too. So get them snug, but don't wrench on them super hard, or you can strip them. Well, wrench on it super hard and strip one of them. It's a little known fact that you don't need 4 screws to hold a motor on. You can get away with 3, especially if you're using Loctite. But then you'll know how hard it is to strip it out. Don't do that. Don't strip it out on purpose, but yeah. Let's find the sweet spot. Next, get these 2 plates from the frame kit. And I want you to notice that this plate has press nuts in it, and they are going to be facing up, and the flat side, the flush side, is going to be facing down. This one is going to go here, and these screw holes are going to line up with these screw holes in the motor plate, like so. And then this one is going to go on the bottom, and it's going to line up like so. Okay, that's how it's going to go. And then we're going to get screws from the frame kit, and we're going to put that together. From the screw assortment that came with the frame, we're going to choose this M3 screw and these 2 slightly shorter M3 screws. And what you can do is just take a scissors or something and just slit the end there so that you just take those ones out and you don't make a big mess of everything else that you're going to use for the build. We're going to use a 2mm driver. We're going to put these screws up through the rear two holes, the shorter ones, that is. All right, and then they are going to go into these back two press nuts. And again, with the press nuts, you're going to want to tighten them down snugly, but you're not going to want to overdo it because they are relatively easy to strip out if you go ham on them. And I want you to take a closer look here. Whenever you're installing screws in press nuts, do you see how the screws just come flush with the top of the press nut? Again, same as the motors, that's what you're looking for. And ideally, the frame designer will have given you the correct length of screw, but sometimes it's a wild world out there and you may need to adapt. If you're trying to size it yourself, you want them either just flush, or if you can't get it exactly right, I'm okay with having them stick up a tiny bit, like a 0.5 millimeter, because I really do want that full engagement of the threads so that they don't strip out. But that's what we're looking for ideally. We're going to take the other M3 screw, the slightly longer one, and the reason it's slightly longer is that it's going to go through this plate. So we're going to take this plate here, we're going to line it up here and insert this screw through it. Actually, it'll be easier to do if I just stick it through and stick this in the center hole. And then I'm just going to loosely install that because we've got a few more screws to put in. If you do loosely install screws, make sure you go back and get them later and finish tightening them down. Then we're going to take these two longer M3 screws, and yes, these are we're almost out of M3 screws. Everything else in the frame kit is M2. There's just these, which we're going to use later. They're the very, very short ones. These are the longer ones. See, I don't really think about how long they are in millimeters. I just am like, well, it's the extra long ones, the medium long ones. Usually that's good enough. We're going to take these extra long ones, and they are going to go in these two holes here. 1, 2. And you may notice that that does not have any press nut. They just slide right in. The reason they don't have press nuts is that they are going to go into standoffs. And I think at this point, I'm not actually going to install the standoffs. I'm just going to leave these friction fit in here. I don't think they're going to fall out. But suffice it to say, we are going to put something on those screws later. So here is what we've got so far. And we've got our sort of basic base of the quadcopter all assembled. What I like to do at this point is put the flight controller on because at this point the sort of basic structure of the quadcopter is defined. Like if something's not going to fit, like obviously it's all going to fit because we've picked it for you, but if I was building my own build and like, the video transmitter's too big or a wire is going to be in the way or something, I would discover that, but I haven't like put the whole frame together so it's all like constricted and in my way. Here's the flight controller, and the first thing I want to do is identify the top and bottom of the flight controller, and I notice that these pads here, it's a little hard for you to read them probably, but they have labels on them, whereas on this side of the flight controller there are no like solder pads or anything. It's just a bunch of components and a couple plugs. So that tells me that this is the top. And then I'm also going to identify the front of the flight controller, which a lot of times a flight controller will have a front-facing arrow indicating which way is front. This one does not seem to have that. But what I do see is that here, these two pads here are going to be for soldering on our battery lead. So you've got these two pads here. They're labeled plus and minus. And then we've got 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. These are the solder pads for our motor. So each motor has 3 wires, and the ESC is going to have 3 pads for each motor to solder to. And since in this case our ESC and our flight controller are the same thing, that's referred to as an all-in-one flight controller. It's not really everything in one. There's other things that anyway, they call it an all-in-one. I could recognize those components. I'm going to assume that the battery lead is supposed to come out the rear. If I get my frame, here on the frame, okay, so first of all, this is the front of the frame, and this is the rear. How did I know that? Well, it's my frame. Of course I know that. But you can see these little slits here, and these slits are for these slits are for the camera plates that hold the camera. And so that's telling us that that's the front. And then for the flight controller, there are these mounting slots here, but if you look at the mounting holes of the flight controller, you can see that that's not going to fit. You see that these slots, these diagonal slits here are too narrow. They're too small. They're too close together. Therefore, mounting a different type of flight controller. But we've also got these 4 holes, 1, 2, 3, 4, and that's going to be what we use to mount this flight controller. And what that does mean is that this flight controller is going to mount 45 degrees diagonal. A lot of flight controllers, you would expect they would mount square, and a lot of them do. But this style of flight controller, this is a 25 millimeter spacing, all in one. And for historical reasons, they mount diagonally. So I'm going to assume that it's going to mount like this, with the battery lead coming out the rear and the USB port coming out the side. I don't think it makes sense to do it any other way. If we did it like this, battery would be coming out the front. That's not usually how it's done. We could do it that way. You can actually mount the flight controller however you want. You just have to sort of unwind it in software. But if you mount it the standard way, life is easier. USB on the back left, battery on the back right. And for this one, we're going to get these 4 extra super duper long M2 screws. These are going to be what's referred to as stack screws. And they are going to hold, do they need to be that long? I don't think they do, because we don't have anything on top of here. I think we can use the shorter ones. Yeah, let's take the shorter ones. I'll show you why. Let's try these slightly shorter ones. That's probably why they have 2 sets of screws. If you weren't using an all-in-one flight controller, which is just a single board, then you might have a separate flight controller and ESC stacked on top of each other and need longer screws. I bet these screws are going to work. So we're going to run those up through these holes like so. That's going to be just about perfect, I think. Do we need spacers? Do we need additional spacers? What I'm checking for is that there is sufficient clearance between the flight controller and anything on the bottom of the frame. We definitely don't want anything electronic touching the frame. The carbon fiber is conductive to electricity. It'll short out and it'll destroy the flight controller and maybe other things. But we also don't want, like, you see this plug right here. We don't want this plug making contact with the bottom of the frame. And we can see that it isn't, but not by very much. And the reason we don't want that is, number one, like in a crash, the impact could damage it. But number two, we don't want to transmit vibration to the flight controller. So the flight controller has a gyroscope sensor on it, and that gyro is essential to the flying of the quadcopter. And if vibration is getting to the flight controller, it'll mess up the gyro and make the quadcopter fly bad, or maybe not at all. If I look at these screws, I can see that I have a lot of thread on those screws. I can stand to space this up a little bit. I know what to do. I know exactly what I'm going to do. I'm going to put these 4 screws in, 1, 2, 3, 4, and then I'm going to get these M2 nuts. And actually, it comes with extras, and I know why. I'm going to take these nuts and put them onto the screws, and they're going to hold the screws down rigid. In addition to holding the screws in, they're going to add a little bit of spacing at the bottom. Get on there. And these appear to be plastic screws. So again, don't go nuts when you're tightening them down or you will strip them out. If you want to be extra, you can buy yourself a set of these M2 nylock nuts. And they would be even better for this application. But I'm going to use what you're using for now. If you have those, use them. They're better. In addition to providing some spacing to keep the flight controller off the carbon, these nuts also stabilize these screws. You can see that now they can't wiggle around as easily, or really at all, and that is going to make the flight controller gyro much happier as well. So now we push this guy down, and you can see that there's a lot more space for those plugs. We still have plenty of threads on top to tighten this down. This is a good situation. And what I want is for that nut to just begin to squish and compress this silicone gummy here, but not like crush it down. That gummy is for vibration isolation, and if we put that nut on too tightly and crush it down, it won't be good at that job. These plastic nuts seem to be fairly resistant to backing off. We want to add just enough pressure on it that it won't back off. So like, what I want to do is I want to tighten that down till it starts to bite on the silicone a little bit so that then, see how when I turn the screw, the nut doesn't move? And that means it's tight enough that it's not going to come loose and back off while we're flying. Again, this would all be solved if I just used nylock nuts with the nylon insert that keeps them from backing off, but that costs extra money. And unfortunately, the next part of the build is the part that is going to drive some of you guys crazy. We have to solder. We have to solder this battery lead onto the flight controller. We have to solder the motor wires to the flight controller. And there's a very good chance that you don't know how to solder. And you're going to be tempted to just power through, and you're going to destroy your flight controller. Well, hopefully that doesn't happen. If you don't know how to solder, if you're just self-taught at soldering, but you kind of know in your heart of hearts that you suck, then you need to pause this video, and there's a link in the video description to my how to solder tutorial. And I know you're in a hurry to get your quadcopter built and go fly it, but you have to take the time. You're going to take a few hours of your life, potentially. The video isn't hours long. You're going to watch that video. You're going to try and absorb that video, and then you're going to get something to practice on. You can buy a practice solder board. I'll put a link to that in the video description as well. Maybe you have the wrong kind of solder. Maybe your soldering iron sucks, and that's why you can't get good results. You're going to go get your soldering situation sorted out. You're going to practice on the practice solder board for a little while until you're getting good results. And that may take a couple hours, but I promise you it's worth it. It will pay dividends for the whole rest of your FPV career, and it will pay dividends in that you will not destroy this expensive flight controller and have to go buy another one. And then when you at least halfway not, I was going to say halfway good, but halfway not shitty at soldering, then come back here and we're going to proceed. But we're not going to do a soldering tutorial in this video because I already made that video. Oh, you're back. Oh, you know how to solder now? Congratulations. Good for you. Let's get on it. And the first thing I'm going to do is solder down my battery lead. The battery lead is already cut to the right length. And I just need to figure out how I'm going to route it. Your temptation may be to just have it come straight out the back, but I don't think you should do that. I think we should sort of cock it to the side a little bit. If we come straight out, I don't know. Yeah, I think we should cock it to the side a little bit. Which is the positive and which is the negative? Yeah, you could just barely see them. If we look super close here, we can see a minus and a plus just next to this LED. So black is negative, red is positive. And I'm going to do it like this, coming straight towards the back, and like this, coming straight towards the back, just like that. The flight controller comes with screws and nuts for mounting as well. Oh, and little standoffs and spacers too. Well, anyway, I solved that problem. In case you wondered whether I rehearse these builds before I do them, now you know. I don't. This component here is a capacitor, and it is like a shock absorber in your car. You know, if your car didn't have suspension, then when you went over a bump, it would be a lot of shock and the car would be damaged and you might be, well, at the very best, uncomfortable. This is like a shock absorber for the electricity in your drone. The motors are spinning and they're making a lot of sort of spikes in the electricity, and that can damage things and mess things up, and the capacitor smooths it out. It's pretty essential for most builds. What we're going to do is... first, we're going to identify, see that's a negative symbol. This leg on the capacitor is the negative leg. The other one, by process of elimination, is the positive leg. We have to get that right. If we get that wrong, it will pop when we first power up. We're going to pass this through these holes. So what I think I'm going to do is lift the flight controller off, and I'm going to take my capacitor, and making sure to get the positive and the negative legs right, I'm going to pass it through from the underside, like so. And I'm going to double check that I've got my positive and my negative legs right. Here's the negative symbol. It's going to the negative pad. And then I'm going to press that up just till it gets close, just enough that I can then bend it sideways like this. And it's basically flush with the pad like that. That's what we want. And then I guess what I'm going to do is I'm also going to just bend these down. We're going to cut them off later, but for now we'll just bend them down like that so it's kind of gets held in place. That's what we're going for. You know, I kind of want to edit this out of the video, but I think it's a good learning experience. I'm not loving this. You see how the capacitor is up against this press nut? Kind of no matter what I do. That's going to create vibration and transmit vibration to the flight controller, which I said we don't want to do. I don't like it. So we're going to lift this guy off. We're going to take the capacitor out, and can we just stick it in the other way? I believe we can. Minus plus. Stick it in from the top. Is that going to work? We're going to have to bend the legs the other way. Damn. Okay, not the end of the world. Here is what we've ended up with. Still negative to negative and positive to positive. Double, triple check. It's coming out the top, and it's bent over, and then we've bent these legs around like so, and it's pretty secure. And this is why I dry fit everything before I solder it down. Then we'll just double check, and now, yes, you see we have no contact. That's better. I like that better. Now the factory XT60 connector comes with solder already on it, but it is probably lead-free solder, and it may be low-quality solder from China. So I'm going to add some fresh, high-quality leaded solder. I'm just going to add that in there, basically tinning, which you know from the tutorial. And I'm going to get my flux pen out, and I'm going to apply a little bit of flux. All of these things set me up for success with soldering, and I'm going to go ahead and tin these pads. Ooh, that's going to be a little tricky. Let me turn that so I can, how can I get at that best? And now I can cut these legs off. And you want to make sure that you don't leave any of the leg hanging down below the flight controller, because if it contacts the frame, it's going to be bad. Now this is going to be a little tricky because I want the battery coming off this way, but now the capacitor is in the way. It's really important to put the capacitor as close to the ESC as possible, because that makes it the most effective. Some people will install the capacitor like on the battery lead itself, like literally right up here, and it makes it easier to mount because it's not in the way, but it also makes it completely ineffective. So here's what I think I'm going to do. We're going to do the positive wire coming straight off here, and I want you to see that my solder has blobbed over onto this component here. That is fine. That is okay. That's okay. If the solder blobs between these two pads and bridges the positive and the negative, that is bad. You would need to fix that. And then I think what I'm going to do is bring this kind of like over the top like that and down in. Ooh. That's a lot to ask of somebody who is new at soldering and building, but that's the right way to do it. And I definitely want to show you the right way to do it. Let's take a closer look. One of the things you want to look out for is, as I said, there is no bridging between these two pads. The sort of bulbous nature of this joint tells me that there's too much solder there, but I'm going to call it good enough. It hasn't flowed over. So I think it's got good contact and everything. It's just cosmetically not ideal. And you'll notice that we haven't messed with this component at all. We haven't flowed any solder onto these pads, which I think would also be bad, although I'm not 100% sure. As you're going in here with your soldering iron tip, you have to be super careful also not to like knock this off or any of that. Just you gotta be real careful and try to be real smooth, and good luck. I don't know. Maybe a Sub250 shouldn't be your very first build. Well, too late now. Before we continue with the video, I'd like to remind you that the single best way for you to help make sure that I am able to continue making content like this, which hopefully you value, is to join my Patreon. Patreon is a website where you subscribe to me for as little as $2 a month. That's the minimum amount, just $2 a month. Someone's vacuuming. But join my Patreon, get access to my Discord server, and just feel good about supporting the work that I do here. If you watch my content regularly, then hopefully eventually you'll come to a point where you go, this guy's earned my support. If today is that day, join my Patreon at any level, at any dollar value that you pick. $2, pick $5, pick $10, pick whatever amount you think is fair for the amount of value you get out of my content. There's a link down below where you can click through. And if today's not the day, if you're like, I just want to watch the video, you've probably already skipped ahead. But yeah, keep watching the content. I'll keep making the content, and I hope that day comes. Next up, we're going to do the motors. And as I said previously, each motor has 3 wires coming off of it, and there are 1, 2, 3 motor pads. I want you to identify these 1, 2, 3. Right. Then here we've got 1, 2, 3. Each of the motor pads has one of these little square components. That's a MOSFET, or a FET for short. 1, 2, 3 here, and 1, 2, 3 here. Don't mix these 3 pads up with this little cluster of smaller pads, which we're going to use later. Each of the 3 wires from the motor are going to go to the 3 motor pads that are facing that direction. But don't just tug the wires out like this. We don't want any tension on these wires because, again, we're going to crash this thing. It's going to be subject to shock and vibration and flexing. So what we want to do is we want to take these wires. You see they're way too long. What some people will do is they'll just solder them up like this, and then they'll try and tangle. Don't do that. That's just a mess. That's not a good build. What we're going to do is we're going to take these wires, we're going to stretch them out, we're going to kind of lay them down with our finger, right, flat against the arm, lay them across these pads here, and then leave a little slack. Like I'm going to leave myself maybe like a generous centimeter of additional wire, right, and we're going to cut them off so that then when we solder them up, they're kind of going to look like this. And they'll have a little slack in them and a little room to work with, but not like a ridiculous amount. So we'll cut that. If you cut them too short, you're boned. You're boned. So don't cut them too short. Cut them a little too long rather than a little too short. And I'm going to strip and tin them per the soldering tutorial. And I'm going to solder them down. I'll show you me soldering them down one time just so you can see what this exact board looks like to solder it down. To be honest with you, that's a little bit longer than it ideally needed to be. You see, it's a little messy there. And you'll also notice that I have not wired them straight through. I've accidentally crossed the wires. I'm probably going to shorten these up just a little bit. You don't have to if it's you. And the other thing is, which wire goes where on the ESC? It turns out it doesn't matter. You have 3 wires on 3 pads, and all that matters is that those wires go to those 3 pads. And the way that a brushless motor works is the order that you put the wires determines whether the motor spins clockwise or counterclockwise. So which is this? There's no way to know. Is this a clockwise or a counterclockwise spinning motor? There's no way to know. What you do is you just solder the wires up straight through so it looks neat, and then in software, we're going to change the motor direction later. If you ever are in a situation where the motor is spinning the wrong direction and you need to reverse it, a good tip is that you can swap any 2 of the 3 wires, and the motor will reverse directions. But basically it doesn't matter because you can just do it in software most of the time. I'm going to go ahead and solder up the rest of these motors off camera, and I'll see you back here when I'm done. Here's what we're shooting for when all is said and done. I have zip tied the wires neatly to the arms. That's to help keep them from getting snagged or cut up by the props. In fact, I actually found it easier to zip tie the wires before I soldered them down, although I'm not sure that would be easier if you didn't have a lot of experience doing this. Maybe, just a little tip for your next build, maybe. And the wires are neatly run out of the way of any screws. Like this one here goes really close to the screws, and I actually soldered them a little cocked to the side so that they would clear that standoff. So you're going to want to watch out for that, but there we go. Let's zoom in a little bit and take a closer look. Do a visual inspection to make sure that there are no solder bridges between any of the motor pads. And you generally don't want to see solder extending up to touch the FET, although it doesn't matter because these are the outputs of the FET. So if it did bridge a little bit here, that would be, well, not ideal, but not a showstopper. But you definitely don't want any bridges between, any touching, no strands of wire or anything between the pads, or you will potentially destroy the ESC or the motor when you first power up. So we'll just run through that visual inspection. They're looking good. We don't want to see any wire extending back here. If the wire is extra long and sticks out, that can be an issue. We want those wires to be just about the right length. The ideal length is, as I said in the soldering tutorial, about the same size as the pad that you're soldering to. So we also don't want to see a bunch of wire sticking out this way with bare wire here. We want that insulation to go all the way up to the edge of the pad and have the wire be fully contained in the solder joint. Here we go. We got this one. This was the first one I did, and the wires are not quite the ideal length, but we've got them tucked out of the way. And over here is the final one. Yeah, that's what we got. At this point in the build, I like to do what I call a smoke check. We're going to do a basic test with a multimeter to make sure that we haven't made any gross mistakes in wiring this up. And then we are going to apply power and see if anything blows up. And the idea is that we haven't quite finished the build yet, but we've done most of the places where we might make a mistake that would blow things up. And so we may as well check that before we get too much deeper in. In order to do this, we're going to need a multimeter. If you don't have a multimeter, it's time to get one. They don't have to be expensive. They can be as little as like 15 or 20 bucks, maybe even less. Even a cheap one is fine. This is the one I use. It's on my ultimate FPV shopping list. You can find links to it there. Just get one. You get one at freaking Walmart. And what we're going to do is we're going to put the multimeter into continuity check mode. That is the mode with this little symbol that looks kind of like a Wi-Fi symbol. It actually is supposed to be the representation of a speaker, because when there is continuity between the two probes, they will make a sound. And basically, we can use this to test if two things have electrical connection to each other. So the first thing I'm going to do is I'm going to take my XT60 and I'm going to put the black multimeter probe on the negative pin of the XT60 and the red multimeter probe on the positive pin. And what I want to hear is no beeping. Great, no beeping. That's what we want. And then I'm going to reverse them. The red probe on the negative, and we want to hear no beeping. Oh, we heard a beep there. If there's a short beep, that stops. That's okay. That's just the capacitors in your build charging up, and once they charge up, then the current stops flowing. But if we get a continuous beep, then there's a short circuit between positive and negative, and you must not plug a battery in until you figure out where that short circuit is coming from. I highly recommend you pick up one of these. This is a smoke stopper. The exact one brand of this is the ViFly Short-Saver V2. It costs like 15 bucks, but it will save you someday blowing up a $100 ESC. And what this does, it acts kind of like a fuse or a circuit breaker. If too much current is flowing, it cuts off power and it protects you from some mistakes that would blow your stuff up. So we're going to plug this into the quadcopter and we're going to get one of our batteries. We're going to plug that in. Nothing will happen because the smoke stopper has not turned on yet. This one has a switch that we need to press to turn on. We're going to go ahead and press that switch. That may have happened as soon as you plug the battery in, and that is what we wanted to hear. Those beeps mean that the ESC and the motors are alive, the flight controller is lit up, and most importantly, no smoke has come out of anything. We are ready to proceed. The next thing to do is going to be to install the video transmitter. And this is where we're going to get into a little bit of a choose your own adventure scenario, depending on which video transmitter you're installing. See, it would be silly of me to make all the people installing Walksnail sit through the install of the DJI O4 Air unit that they don't really care about, and vice versa. So this video is going to come to an end, and a playlist is going to appear on screen, a card for a playlist, and there's a link to a playlist in the video description below. And the next video in the playlist is going to be installation for a Walksnail, and the video after that is going to be installation for the O4 Air unit, and then after that, analog, and you're going to go watch whichever one of those is right for the video transmitter you're installing, and then we're going to bring it all back together to install the receiver and finish the setup. I'll see you there.